Hello everyone and welcome back to science class. Today I want to talk to you about how the ground acts as a carbon sink, and I also want to talk about a special kind of ground called permafrost. So we know that the ground stores carbon in the form of complex carbon molecules. You see here this log? This log is rotting. It's decomposing. That means that it's slowly being returned to the earth. We know that decomposing organisms bring carbon back into the ground. We also know that they release carbon to the air, but we're gonna just talk about the ground today. Now, not only do decomposing organisms bring it back to the ground, but also the process of sedimentation. Sedimentation takes soil, small rocks, sand, silt, and it compresses them into hard rock. So those are the two ways that we have carbon that gets stored in the ground. Now remember, fossil fuels is an example of decomposing organisms that have been trapped underground for millions and millions of years. Now, permafrost is a very special type of ground. It is ground that is frozen all year round. In fact, it has to be frozen for at least 2 years in a row for it to be considered permafrost. We typically find permafrost in really cold areas like the Arctic or Antarctica, or even in the high altitudes of high mountains. Because the ground is frozen, plants can't really live there. Only plants that have a very short root system can live there. So you can't expect trees to grow where there's permafrost. You can only really expect grasses and shrubs, mosses and lichens to grow in these regions. We often call these regions the tundra. Now, these regions are not always covered in snow. In the summer, they actually do have some small shrubs and plants growing in this type of soil. You see, permafrost has two different layers. There's the top layer, which can be as shallow as a couple of inches or as deep as a couple of feet. And then there's the bottom layer. So the top layer is the active layer. That's where all of the growing happens. Below the active layer, that's where you have the icy layer. This icy layer is made up of sand, soil, silt, and ice. The ice makes this ground really hard. So a lot of communities in the north build their structures and their roads on the permafrost ground without needing to dig a deep foundation. They can basically just build on top of the ground and not have to worry about the ground shifting underneath their buildings. Now, permafrost is also a huge way to store carbon. It stores carbon through dead organisms. You see, when dead organisms get compressed into the permafrost soil, the actual temperature of the soil prevents these organisms from decomposing. So there are dead plant organisms and dead animal organisms in the permafrost that haven't even started to decompose yet. Now, also trapped in the permafrost are ancient bacteria and viruses that we have never ever seen before. With the rise of global temperatures and the melting of the Arctic, we are starting to see the permafrost starting to melt as well. And this has a lot of problems. Melting permafrost can cause damage to infrastructure such as roads and buildings, and it can also cause a lot of land erosion and sinkhole formation. Heck, even the permafrost along the coast is collapsing into the very oceans. There's coastal erosion happening. The very shape of the land is changing because the permafrost is melting. Not only are infrastructures being destroyed and the land is changing, but the frozen dead organisms in the permafrost are starting to thaw, which means that they're starting to decompose. This means that there's going to be a lot more greenhouse gases being released from the soil in the form of carbon dioxide and methane from the decomposing organisms. And of course, to top it all off, when the permafrost thaws, that means that those bacteria and the viruses that are in the soil that we've never seen before are starting to emerge, which means that we're basically opening the door to more pandemics if we continue to allow this to happen. The melting permafrost is a big issue that we need to take care of. And to take care of that, we need to take care of the problem of climate change in general. Thank you for listening, and I will see you all next time.